Hi everyone, this lesson is about simplifying algebraic fractions, and when we're presented with something like this we have to remember our basics from primary school about order of operations. We do multiplications and divisions before we do additions and subtractions, and we have to remember things like when we add fractions we have to have common denominators, all those fundamentals. Now a clue for things like this is to factorise everything first. Our life will be much easier. So let's see how we go. If I look at this first expression, I notice that I have a common factor of 3x. And that would become x plus 1. It still has a denominator, x take 3. And now we're multiplying. Let's factorise this as well. The numerator for this one is a quadratic, it's a monic quadratic, so I'll just do my little table. A multiplied by C would be 12 and B equals negative 7. I need to think of numbers that multiply to give 12, so I could go 1 times 12. Now here's a problem. If I add two positive numbers I'll never get a negative number. I need a negative number, so I must be talking about two negative numbers here. Now they still multiply to give 12 but they don't add to give correct, so let's try negative 2 times negative 6. They don't work. Let's try negative 3 times negative 4. Now that's okay because negative 3 plus negative 4 does add correctly. Those are my numbers. It is x subtract 3, x subtract 4 as the factorisation. Now my denominator for this one has a common factor of 6x, and that would leave x plus 1, and I still have plus this bit over here, x plus 5 over 3. Now, order of operations. I must multiply before I add. So here I go. Now with multiplying fractions, that's easy. We multiply the numerators and we multiply the denominators. And I'm just going to leave them all written in factorised form. Multiplied by x take 3, multiplied by x take 4. The denominator 6 times x multiplied by x plus 1 multiplied by x take 3. That's the denominator, plus, and over there we have x plus 5 over 3. Now remember, when I've got a fraction and all the terms in the numerator and all the terms in the denominator are multiplied, I can cancel things which are the same. So not worrying about the x plus 5 over 3, just worrying about this big giant fraction I've got. I can cancel the x plus 1 term. I can cancel this binomial term because they're in common. I can even cancel the x with itself, and I can say 3 goes into itself once, 3 goes into 6 twice. So I have a much simpler looking problem now. The numerator is x take 4. 1 times x take 4. The denominator is 2. Added 2, I have x plus 5 over 3. Nothing's changed there. Now, adding fractions need a common denominator, and the quickest way is to multiply the denominators together, isn't it? So if I go 3 multiplied by on the top and bottom of that fraction, and if I go 2 times on the top and bottom of this fraction. Oh, sorry, that should have been a black equals sign. And now what do we have? 2 times 3 is a common denominator, 6. Expanding out, 3 times x, 3 times negative 4, that's minus 12, plus 2 times x, that's positive 2x, plus 2 times 5, that's a positive 10. And now collecting like terms, 3x and 2x are 5x, negative 12 plus 10 is minus 2, divided by 6. We have simplified this expression considerably. Now, I'm just going to show you a quick little way to check you're working. So, of course, you can look in the answers in the back of the book, but we could do this. There's my first expression that I was given, in all of its lovely complexity, and I just entered this into my graphing calculator here as y equals this lovely function, and it turns out to be this beautiful green straight line. Now here's my answer. I entered the answer, y equals, and if it truly is the same thing, when I hit the button here, it turns out to be exactly the same picture on the graph. That shows me that these two algebraic expressions really are doing the same thing. They are equal to one another. Okay, that's it. Thanks for watching.